Let's now look at an example in which the population mean is still 60 and the standard deviation is still 10, but the 5 heights have changed. Well, we know that this person who's 50 inches tall has a z-score of -1 because if you start at 60 and go down by 10, you get to 50. And we know that all of these people who were 60 inches tall have z-scores of 0 because they're right at the mean. And we also know that this person who has a height of 80 inches has a z-score of +2 because if you start at 60 and go up by 10, that's 70. And if you go up by 10 a second time, that's 80. Once again, we can look at a visual. So this time we have one person with a z-score of -1, 3 people with a z-score of 0, and 1 person with a z-score of +2. And I hope these diagrams make it clear that people who are more extreme and are further away from the mean have bigger z-scores, because people who are far above the mean in this direction have z-scores that are big positive numbers, and people who are far below the mean in this direction have z-scores that are big negative numbers. So if we kept on going, if we extended this number line, eventually we would have a tick mark for 100, and that would be +4. A person with a z-score of +4 would be pretty far above the mean, because they would be 100 inches tall. Also, if we extended the number line in this direction, eventually we would get to a height of 10 inches, which would be a z-score of -5. That would be pretty far below the mean. So basically, a person who has a big positive z-score is far above the mean, and a person who has a big negative z-score is far below the mean. So far we've been finding people's z-scores by just starting at the mean and counting upwards by standard deviations, or by starting at the mean and counting downward by standard deviations. And it might have seemed like I was doing it the hard way. You might have been thinking, isn't there a formula that can be used to find a z-score? Well, there is actually a formula that can be used, and the reason why I was doing it the hard way is just to make it clear what a z-score actually stands for. I wanted to make it stand out that a z-score is just the number of standard deviations. But now at this point, I think a z-score is conceptually clear. I think you understand the concept of a z-score, so from now on we'll just use the formula to find z-scores. And this is the formula. The formula for a z-score is just the data value minus the mean divided by the standard deviation. So like I said, we could have used this formula all along to find the z-scores, but I was doing it the hard way to help you understand the concept of a z-score. If you wanted to change this to symbols, x is the symbol for the data value. Mu, the Greek letter mu, is a symbol for the population mean, and the Greek letter sigma is a symbol for the population standard deviation. Now let's go through an example of using the formula to calculate a z-score. So we have a person who's 45 inches tall, and that person is a member of a population that has a mean height of 70 and a standard deviation of 7. So the entire population that this person comes from has a mean of 70 and a standard deviation of 7, and this individual person has a height of 45. And we want to find out this person's z-score. To find this person's z-score, we just subtract the person's data value of 45 by the mean of 70 and divide by the standard deviation of 7. So we can do this in just a few steps. First, we have to subtract on top of the fraction. So 45 minus 70 equals -25. Now that we've subtracted on top of the fraction, we just divide by the standard deviation on the bottom. So negative 25 divided by 7 is negative 3.6. So the person's z-score is negative 3.6. So we've subtracted on top first, and then we divided by 7 on the bottom. 45 minus 70 was negative 25, and then negative 25 divided by 7 was negative 3.6. So now we have a person who's 85 inches tall and comes from a population with a mean height of 70 and a standard deviation of 7. We're going to use the same formula to find this person's z-score. And since this person is above the mean, this person's z-score is going to end up being a positive number. So 85 minus 70 equals 10. I'm sorry, 85 minus 70 equals 15. And 15 divided by 7 is 2.1. So this person's z-score is 2.1. So I hope this formula is also making it clear that a z-score doesn't have to be a whole number. It can have a decimal at the end. Now let's go through an example in which we find the z-scores of these three heights. And we're going to use the formula to find each of these z-scores. Let's start with this person who's 50 inches tall. Well, this is telling us that this person comes from a population with a mean height of 60 and a standard deviation of 8. So we're going to subtract the person's height of 50 by the mean of 60 and divide by the standard deviation of 8. 50 minus 60 equals negative 10, and negative 10 divided by 8 is negative 1.5. So this first person has a z-score of negative 1.25. All three of these people are coming from the same population. So this person who's 55 inches tall also comes from this population with a mean height of 60 and standard deviation of 8. So to get this person's z-score, we're going to subtract by the same mean of 60 and divide by the same standard deviation of 8. So 55 minus 60 is negative 5 on top, and negative 5 divided by 8 is negative 0.625. This is the z-score of person 2. So we can see that, so far we can see that since these two people are both below the mean of 60, they both have negative z-scores. Now what about this person right here, who's 60 inches tall? This person is right at the mean of 60, so we already know that that person's z-score is going to be 0, but let's go through the formula just to show that that's true. We take the person's height of 60, subtract it by the mean of 60, and the top comes out to 0. And 0 divided by anything equals 0, so this person's z-score is 0. So these are the z-scores of the three people. We've just taken these three heights and we've changed them to z-scores. So I hope that this makes it clear that each person has both a data value and a z-score that goes along with the data value. The z-score just shows the number of standard deviations that the data value falls below or above the mean. Here's one more example. This example is a little bit different because now we're imagining that these three people make up the entire population. This is a small population of 3 people. So it looks like it's 3 students who are in a class together, and they've all taken an exam. And we want to find the z-scores of these 3 people. And we actually don't know what the mean and standard deviation of the population are. But since we know that these are the only 3 people in the population, we can actually use their data values to calculate the mean and standard deviation of the population. So in this example, we're going to go through a few more steps. We're going to actually calculate the mean and standard deviation of the population, and then calculate the z-score of each of the 3 people. So first, let's find the population mean. To get the population mean, we just add the exam scores of all 3 population members and divide the total by 3, because there's 3 of them, and we get 80. So the mean exam score of this small population is 80. Now we have to find the standard deviation of this small population. Well, to get the standard deviation, we just subtract each data value by the mean of 80 to get the deviations. The deviations are -5, 0, and +5, because this value is 5 below the mean, which means the deviation is -5. This score is at the mean, so it has a deviation of 0, and this score is 5 above the mean, so it has a deviation of +5. Now we have to square each deviation, meaning we have to multiply each deviation by itself. So -5 times -5 is 25. 0 times 0 is 0. 5 times 5 is 25. The next step in finding the standard deviation is to calculate the mean of the squared deviations. So there's 3 squared deviations here. So to get the mean of the squared deviations, we just add them and divide by 3. And we get 16.7. Also remember that when you're calculating the standard deviation of an entire population, like we are here, you don't drop this number down by 1. It just stays at the number of squared deviations. So we don't drop this down to 2, it just stays at 3. And remember that the mean of the squared deviations, which we just found right here, is called the variance. So we have a variance of 16.7, and the standard deviation is the square root of the variance. If you calculate the square root of 16.7 by just hitting the square root key, it's 4.08, or it rounds to 4.1. So this population has a standard deviation of 4.1. Now that we know that this small population of 3 people has a mean of 80 and a standard deviation of 4.1, we now have all the information we need to get the z-score of each person. So what we're going to do is we're going to take each person's exam score, subtract it by the mean of 80, and divide by the standard deviation of 4.1 to get the person's z-score. Let's start with person 1. 75 minus the mean of 80 is -5, and -5 divided by the standard deviation of 4.1 is -1.2, because -5 divided by 4.1 is -1.2. So we know that person 1 has a z-score of -1.2. To get the second person's z-score, we subtract the second person's exam score of 80 by the mean of 80 and divide by the standard deviation. 80 minus 80 is 0, and 0 divided by 4.1 is just 0. So like I said, a person who's right at the mean will always have a z-score of 0. Now we need to find the z-score of person 3, who has the exam score of 85. So 85 minus the mean of 80 on top equals +5, and +5 divided by the standard deviation of 4.1 is 1.2. So now we've just found the z-scores of all 3 people. And we can make a column right here to show each person's exam score and each person's z-score. Now we're almost at the end of the video. I wanted to make a few more points that'll sort of be a preview of some topics that'll be coming up in the future. One important point I wanted to make is that if a population follows a normal distribution, then it's possible to calculate how many people fall below a certain z-score above a certain z-score, or between two z-scores. And here are some common examples that I'll share with you. If a population follows a normal distribution, then 68% of the population has a z-score between -1 and +1. 68% of them fall in here. Only 16% of the population has a z-score below -1, and only 16% of the population has a z-score above 1 out here. Also, if the population is normal, 95% of the population has a z-score between -2 and +2. Only 2.5% of the population are out here below -2, and only 2.5% of the population are out here above +2. And if a population is normal, it turns out that 99.7% of the population has a z-score between -3 and +3, and only 0.15% are out here below -3, and only 0.15% are out here above +3. And these percentages that I just shared with you are actually always correct if the population is normal. It doesn't matter what this standard deviation actually equals. It doesn't matter what the population standard deviation is. And in a later topic, we'll actually talk about how it's possible when a population is normal to take any z-score along the number line and calculate the percentage of people above that z-score or below that z-score. For example, if I know that a certain population follows a normal distribution, then I could actually calculate the percentage of the population that's above 1.7 or below 1.7. Or if I wanted to, I could calculate the percentage below -2.3 or above -2.3.